Good morning. These are the e-learning notes for April 13th for Math 1. So today we're going to review the concept of slope, finding slope from a graph line, and finding slope given 2 points, not on a graph. And also we're going to review the characteristics of quadrilaterals. Okay, so first we're going to go through a few examples of finding the slope of a graph line. So reminding you that when it comes to finding slope on a graph line, we want to locate 2 points on that line, and we want to use the concept of rise over run. Okay, for a graph line, we want to find slope. It's rise over run. Alright, so I'm going to start with this point down here. And I want to make my way to this point in the line. So I'm going to have to rise 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Make sure I count these boxes correctly. So it's a rise of 6. So my slope is a rise of 6, and it's positive because I went up, and then a run of 1, 2, 3, 4. And so 4 boxes to the right. So up 6 boxes, to the right 4 boxes. So it's a slope of 6 over 4. Now I can also reduce the slope. 6 and 4 divisible by 2. So I have my slope as 3 over 2. Moving on to number 2. Again, we want to find the slope of this line. We're going to use these 2 points. Find the slope. Again, we are doing rise over run. Go ahead and put my fraction bar there. So I'm going to start with this point, and I'm going to go down 1, 2, 3, 4, 5, 6, 7. So down 7. Because I went down, my 7 is going to be negative. Okay. And I started at this point and went down 1, 2, 3, 4, 5, 6, 7 boxes. And it's negative 7 because I went down. And then I'm going to go to the right 2 boxes. Because I went to the right 2, it's going to be a positive 2. Now I cannot reduce this. 7 and 2 don't have a common factor that I can reduce them by, so I'll leave it as negative 7 over 2. Again, I can write it like this as well. Now one thing I want to remind you again, when you're looking at a graph line, right, looking at these 2 examples, here we calculated a positive slope. And again, our line with a positive slope should be slanting upwards from left to right. And then that should be a positive slope for any line that's slanting upward from left to right. Here we calculated a negative slope. Again, any graph line that has a negative slope will have a line slanting downward from left to right. Okay. Then we're going to look at these 2 special cases for number 3. Again, we're given these 2 points and we want to find the slope of this line. Okay, so now again, we could do rise over run. But again, this is a review. So just remind you that this is a horizontal line. Any line that goes straight across is a horizontal line. And a slope for a horizontal line is always going to be 0. Okay, again, you can go through the motions of doing rise over run. We can do that. Okay. To prove to you again why the slope is 0. So now I want to make my way from this point to that point, so I need my rise number. Now notice I don't have to go up or down to get even with this point, so my rise number is 0. My run number will be 1, 2, 3. To the right. Okay, so again, my rise number is 0 because I didn't have to go up or down. My run number is 3 because I had to go right 3 boxes. But 0 over 3 can be reduced down to just 0. Right? Because 0 divided by 3 is 0. Thus proven again for a horizontal line, the slope is 0. Here we have a vertical line. Okay, so again, let's go through the motions of calculating slope, rise over run. I'm going to start with this point, make my way to that point. I'm going to go up 2, so that's a rise of 2, so it's a positive 2. Now I don't have to run anywhere. I don't have to go side to side anywhere, so my run number is 0. 2 divided by 0 is not reducible. Reminding you again, if you divide by 0, okay, your calculator is going to tell you there's an error message, because anytime you divide by 0, that answer is undefined. Okay, so again, the slope is undefined. And again, this is a vertical line, and all vertical lines have an undefined slope. Alright, so we're going to finish up this side of this part of the notes with finding the slope given 2 points. Alright, so again, they're not graphed. So again, we are going to first label our ordered pairs. So this is my x1, y1, x2, y2. Again, very similar to what we did for distance. But again, we are calculating slope. So we're going to use the slope formula. So again, reminding you, I'll write it up here. The formula for slope, y2 minus y1 over x2 minus x1, or if you want to do y1 minus y2 over x1 minus x2, either one's going to work. Okay, so again, for number 5, we're going to, since we labeled our ordered pairs, let's go ahead and plug it in for slope. So I'm going to go ahead and use this first one, which says I'm going to do y2 minus y1. So my y2 number is 19. I'm going to subtract y1, which is a negative 16. x2 minus x1. So I have 19 minus a negative 16 is 35. 8 minus 3 is 5. And that reduces down to 7. So my slope is 7. Go ahead and label my next ordered pairs, x1, y1, x2, y2. Again, following the formula for slope. Got to make sure you plug in these numbers in the right spot in the formula. So again, I'm going to do y2 minus y1. x2 minus x1. And there's my slope. Alright, so the last thing we're going to review here today is the characteristics of quadrilaterals that we talked about a couple months ago. So the 4 quadrilaterals that we're going to focus on are parallelogram, rectangle, rhombus, and square. Okay, so again, this is a review. So here for parallelogram, we have opposite sides are parallel, meaning the opposite sides are going to have the same slope. And what parallel means same slope. For a parallelogram, the opposite sides are congruent. Remember, the word congruent means the same, so the opposite sides have the same length. And I'm going to put a little notation here that, hey, when we talk about length, we're talking about the distance from corner to corner. And so here are the characteristics of a parallelogram. On number 2 is a rectangle. There's 3 characteristics for a rectangle. Opposite sides are parallel, meaning they have opposite sides have the same slope. Opposite sides are congruent, meaning again opposite sides have the same length. And the rectangle has one more characteristic than a parallelogram, and that we all know it has 4 right angles. And for us, that means a consecutive side, right? That means 2 sides in a row. Consecutive sides are perpendicular. Reminding you that when we talked about perpendicular in class, that means the slopes are opposite reciprocal. Right? Perpendicular means slopes are opposite reciprocal. And here's an example again when we're talking about slopes that are opposite reciprocal. For example, if one slope is 3 over 2 and it's positive, the opposite reciprocal of that would be negative 2 over 3. Right? Opposite signs, positive, negative, reciprocal. We are flipping the numbers. Right? So 4 right angles means consecutive sides are perpendicular, meaning the slopes are opposite reciprocal. Right? Now the nice thing about the last two is they are kind of an overlap of the previous characteristics. So let's finish off with rhombus. It has 2 characteristics that you want to know of. Opposite sides are parallel, meaning again opposite sides have the same slope. And it has all 4 sides that are congruent. All 4 sides have the same length. For a square, opposite sides are parallel. Opposite sides have the same slope. All 4 sides are congruent. Means all 4 sides have the same length. And finally, a square we know has 4 right angles. And again, 4 right angles means when you see the triangle, you see the rectangle, the consecutive sides are perpendicular, meaning the slopes are opposite reciprocal. Okay. So this set of notes is very important that we're going to be using it, we're going to be using it for the next lesson and assignment. Okay. Alright, so you guys have a great day.